Hi, my name is Jorge Contreras and I'm going to explain independent variables. Independent variables are variables that are independent, as they say, from any other circumstances, such as, for example, if I roll a dice, it's independent completely. Nothing is affecting these dice. If I have two dice and then I throw both dice, independent of whatever I get in one dice, it will not affect the other one. But, for example, with cards, if we play cards and I get these five aces, it does affect which is my next card because I cannot get again a five aces. Sorry, it's five aces. I cannot get these cards again, meaning that this is dependable about what I get. But this isn't dependable of anything. Independent variables are normally tend to be variables that are, as I say, independent and doesn't require any other thing to happen.
In probability and statistics, a random variable is a variable taking on a numerical values determined by the outcome of a random phenomenon. A discrete random variable has a countable number of possible values. The probability of each value of a discrete random variable is between 0 and 1, and the sum of all probabilities must be equal to 1.
The third problem, letter C, we have the probability of A equals 5 over 6 and the probability of B happening once A has occurred is equals to 3 over 4, leaving us to find the probability of B. Now, this meaning that we need to find the probability of B happening after A has happened. The formula for solving this is P equals to the probability of B and A over the probability of B, which gives us 3 over 4 equals 2 probability of B A over 5 over 6. This we can send over to this side and multiply, leaving us with 5 over 6 times 3 over 4 equals 15 over 24, which can be simplified to 5 over 8. Now we have this.
Hi, I'm Guillermo and I'm going to explain problem number 5 of lab part 2. Hello, I'm Guillermo and I'm going to explain problem number 5 of lab part 2. The problem says if the probability distribution of a discrete random variable is shown the following chart. And here's the chart. And now it says for part A it says find the value of k. Well, to find the value of k, first we have to include all of the values to make it equal to 1. Then we have to pass to the other side, to the side of the 1, the 1/7, the 1/7, and the 1/5, because those numbers don't have a k. Now with that we could find that 1/7 to find that same denominator, so it could be 35 of 35, 5 of 35, 7 out of 35. And now we have the the common factor. Now we have 3k equals. Now we have the common factor. Now we have 3k equals to 23 out of 35, and now we have that. Now we have to take out the 3 out of the k, so it goes like k equals 23 divided by 35 divided by 3 out of 1. We do the tortilla rule, and the result for k is 23 out of 105. Now we have our value of k. Now for part B, it says find the probability that discrete random variable taking the value of 2. So we could just take the value of 2, that it's 2k, so it's 2 times, we already know our k is that number, so we will multiply that number times 2 because that's the value of 2, so it's 2 times 23 over 100, our value of k. Now for part B, it says find the probability that discrete random variable taking the value of 2. So we could just take the value of 2, that it's 2k, so it's 2 times, we already know our k is that number, so we will multiply that number times 2 because that's the value of 2, so it's 2 times 23 over 105, and it equals 46 out over 105, and that's our value of 2. Then in part C, it says find the probability the discrete random variable taking a value less than 3. So we know we won't include the part of the 3, so it goes like we take only 0, 1 and 2, so it goes like k, because that's the value of 0, it goes 23 over 105 plus 1/7, because that's the value of the 1, and then the value of 2 goes like we take only 0, 1 and 2, so it goes like k, because that's the value of 0, it goes 23 over 105 plus 1/7, because that's the value of the 1, and then the value of 2 it's 2 times k, so it's 2 times 23 over 105, and the result of that would be 4/5, and that's the value less than 3, the value combined of 0, 1 and 2. And then for part D, it says find the probability that discrete random variable taking a value other than 0. So we know we won't include the 0 now, so it goes like 1/7, because we know the value of 1 is 1/7, plus 2k, so it's 2 times 23 over 105 plus, and we know the value of 3 equals 1/5, so plus 1/5, the 1 and then the value of 2 is it's 2 times k, so it's 2 times 23 over 105, and the result of that would be 4/5, and that's the value less than 3, the value combined of 0, 1 and 2. And then for part D, it says find the probability that a discrete random variable taking a value other than 0. So we know we won't include the 0 now, so it goes like 1/7, because we know the value of 1 is 1/7, plus 2k, so it's 2 times 23 over 105, plus, and we know the value of 3 equals 1/5, so plus 1/5, and that equals to 82 over 105, and that's our value other than 0, so the value of 1, 2 and 3 combined.